Dear students, today's topic is matrix multiplication and solving algebraic equations by matrix method. A matrix is an ordered rectangular array of numbers or functions called the elements of the matrix. So a matrix is an ordered rectangular array of numbers or functions. Order means the numbers or the functions cannot be haphazard. A matrix is known by the number of rows and the number of columns, and accordingly the order of the matrix is determined. Suppose a matrix has an order n into m, means it has n rows and m columns. And an element ANM means it is in the nth row and mth column. If the matrix element is AMN, NM, then it must be in the nth row and mth column. Now we take a matrix. This is a 3 by 3 matrix, that is there are 3 rows and 3 columns, and this is a 3 by 2 matrix, 3 rows and 2 columns. Matrix multiplication is possible only when the number of columns in the first matrix, let us call it A, is equal to the number of rows in the second matrix, let us call it B. Then only matrix multiplication is possible, and the order of the multiplied matrix will be 3 by 2. This matrix order will be 3 by 2 after multiplication. And generally AB is not equal to BA. That is, matrix multiplication is not commutative. Instead of being a rectangular array, it can be a square array also. That is, the number of columns are equal to the number of rows. In that case, it is called a square matrix. A square matrix is always associated with a determinant, and the determinant has a value. So this is a square matrix, but this is a rectangular matrix. So for matrix multiplication to be possible, we must remember that the number of columns in the first matrix must be equal to the number of rows in the second matrix. And the multiplication is like this. This is to be multiplied by this, plus this is to be multiplied by this, plus this is to be multiplied by this, to catch the first element, that is the element in the first row and first column in the multiplied matrix. And like this, and we can remember like this, the first element will be A1n, Bn1. N depends upon the number of elements. Here we have taken 3 elements. So multiplied matrix will be like this. But general, if there are n elements, then A1n, Bn1 for the first, then A1n, Bn2, and like this. Now we'll solve algebraic equations by matrix method. So we take an equation this is x plus y plus z is equal to 0. Then 2x plus y minus z is equal to 4. And x minus y minus z, x minus y minus z is equal to, is again 4. X plus y plus z is equal to 0. 2x plus y minus z is equal to 4. X minus y minus z is equal to minus 4. 4. In matrix form, we can write this equation, these equations as, we take the coefficients 1, 1, 1, 2, 1, minus 1, 1, minus 1, minus 1. This is a 3 by 3 square matrix, and this we can take x, y, z. So this is 3 by 3 matrix. This is 3 by 1. So multiplication is possible, and the multiplier value will be 3:2. That is, there will be 3 rows and 3 columns, and we put these values 0, 4, 4. We call this matrix as A. This is X and this is B. So A into X is equal to B, or A inverse A into X is equal to A inverse B, or X is equal to A inverse B. So to get the X, this matrix, we have to find out A inverse. B is known. Now this is a square matrix, so it has a determinant, and the value of the determinant is, we'll find the value 1, 1, 1, 2, 1, minus 1, 1, minus 1, minus 1. And the value of the determinant is this element 1, this is minus 1, minus 1, that is minus 2, plus this element 1 into minus 1, minus 1, that is minus 2, then this 1, minus 1, minus 1. Two 1 minus 1, 1 minus 1. This 1 into minus 1, minus 1, minus 2. Then this element minus 2. Minus 1, minus 2. And this element minus 2, minus 1, that is minus 3. 1 into minus 3. We have to find out 1, minus 1, minus 2, and this is now this is minus 1, minus 1. This will be plus 1. This will be plus 1. So it is coming as minus 4. The value of the determinant is minus 4. We will record this value. Now A inverse is equal to the value of this determinant. It is to be put in the denominator, then adjoint of A. So to get A inverse, we have to find the adjoint of A. To get the adjoint, first of all, we have to get the matrix formed out of minors of the matrix elements. And minor means, we can erase this. This is the matrix, and matrix of minors is equal to we want to find the minor of this one, then the column and the row containing that element is to be deleted, not to be taken into account. Then this is -1 and -1, that is -2. -1, -2. Then this for this element, this is -2 plus 1, that is -1. And for this element, -2 -1, that is -3. Similarly for this, -1 plus 1, that is 0. And for this element, this is -1 -2, that is -2. And for this, -1 -1, -2. Similarly for this, -1 -1, that is -2. -1 -2, that is -3. 1 -2, that is -1. Now, to find the cofactors, we have to multiply this matrix by, that is, cofactors of A, say Nm, is equal to -1 to the power n plus m into minor of ANM. That is, cofactor of ANM is equal to -1 raised to the power n plus m minor of ANM. Now for this element, n is equal to 1 and m also equal to 1. So n plus m is equal to 2. So this is positive. But for this element, this will be negative. So just we have to change the sign. So matrix of cofactors. Cofactors. Those, this will remain unchanged, this will be changed, unchanged, change, unchanged, change, unchanged, change, change, unchanged. Now we have to transpose of matrix of cofactors. Transposition means rows are to be changed into columns and vice versa. So this row, first row will become a first column, -2, 1, -3, then 0, -2, 2, then -2, 3, -1. Rows are converted into columns. Now this is called adjoint of A. Adjoint matrix. So A inverse. So A inverse will be minus 1 by 4. So now you have to multiply this A inverse with B. That is A inverse is equal to minus 2, 0, minus 2, 1, minus 2, 3, minus 3, 2, minus 1. And this is to be multiplied by 0, 4, 4. We know how to multiply. This is to be multiplied by this, that is 0 plus this is again 0 and this is minus 8. Then this is 0, this is minus 8, this is 0, minus 8 plus 12, and this is 0, 8, this will be 0 plus 8 minus 4, and this we get minus 4 plus 4 plus 4. This is our A inverse into B. And for A inverse, we have to divide it by minus 1 by 4. That is A inverse B is equal to, we have to divide it by minus 1 by 4. So this is also to be divided by minus 1 by 4. And this is also to be divided by minus 1 by 4. And ultimately we get 1 minus 1 minus 1. Not what, this is 8. So we get 2. Sorry. So we get x is equal to 2, y is equal to minus 1, and z is equal to minus 1. We can verify this by putting these equations. That is 4 plus 1 minus 1. Okay. Thank you.